Good morning all. My name is Sinan and our activity is Sayuswa and Tamil and our project is a small scale infusion management system and our objective is to improve the patient safety and care by automatically monitoring the saline infusion level, that way reducing the need for constant manual supervision. And in our component we have, what are the components we have using is step down transformer, voltage regulator, digital rectifier, capacitor. This is the load cell. We have to using the amplifier and also alarm, buzzer, GSM module, 16:2 cross display, LCD display, Arduino Uno, temperature sensor. This is the SpO2 sensor and heartbeat sensor. It is the set value. This is the switch mode. Coming to this part, this is the saline bottle holder with the load cell. The load cell is containing the saline bottle, and further process my friend will be continued.
Hereafter, I will explain our project prototype components, each and every single one in a detailed way. The minimum voltage is required to run our project prototype is 5 volt of AC. The input to our project, we are gaining 230 volt of AC from the breakpoint, and it is being converted into 12 volt of AC by using a step down transformer. 12 volt of AC into 12 volt of DC, we are using voltage regulator. We need to convert the 12 volt of DC into 5 volt of DC, so we are using voltage regulator. In the conversion of 12 volt DC into 5 volt DC, there may be signal distortion and noise may occur, so that in order to cancel those distortion and noise, we are using capacitor. In the conversion process, we finally get the 5 volt of DC which is required to run our project. We are using Arduino Uno, which is coded with the embedded C coding. It is the 16:2 cross to LCD display, which means liquid crystal display. It is used to show the visual output of our project. Here we are using alarm with the buzzer, which is used for the audio output. Here we are using load cell with the amplifier. The purpose of the amplifier is to receive the signal from the load cell without any signal degradation. GSM, which is also known as Global System for Mobile Communication, it will act as a bridge between our project and the user device. Using temperature sensor, which is also known as thermistor, it is used to measure the body temperature of the patient. Using set value, which is used to set the value for the saline bottle. Heartbeat sensor, in here we are measuring the heartbeat of the patient as well as oxygen level of the patient which is flow in the blood. In our project we are using two modes. For that, in order to operate the two modes, we are using the switch. In mode 1 we are going to measure the vital sign of the patient. In mode 2 we are going to measure the saline bottle level. So let us see our output of our project. So here certain parameters are indicating. The T is represented as temperature and S is represented as SpO2. This is an heartbeat sensor level and S is the sensor mode. Here S is the set value and L is the load value. L is represented as normal, high and low. Now we are going to see the another mode of our project, and here it is indicating that L is represented as load value. Now we are going to measure the heartbeat level of the patient. Here we set 100 as a indication level. If it reaches above the 100, it will notify through SMS and alarm. We are going to measure the heartbeat using heartbeat sensor. If it is going above the level of 100, it will indicate through alarm. So here we can hear the alarm sound. And after that alarm, it will send a message to our phone which is going to be shown in the display. So we can see that notification of sending message through visual display. After that, we will message a notification or SMS in our mobile phone. So here we are now going to measure the temperature of the patient. Here we set the temperature value as 50. If the temperature value rises above the 50, it will indicate through the audio alarm. So we can now demonstrate this too also. So we can see that if it reaches above the level of 50, it will send a notification through alarm and also in a message mode. Now we can see that it will display a sending message in a visual output. So here we can see that sending message of visual output, like the same in the heartbeat sensor. We are going to set the load level of the saline bottle. So we are going to set the set value of the saline bottle. So in order to set the set value, we need to keep it as 0 for the initial, and then we need to add a load in the load cell. Now I am going to give some input value to the set value. So we can see that above the 23, if the load is high or low, it will indicate through the alarm. So now the alarm is notified and the SMS is sending through our mobile. Finally, in the end, we discussed about each and every components of our project and their functionalities and output of our project, and that's all. Thank you.